Well, I can't tell you exactly why, except it's been holidays and visitors and family, and there's something about starting a project in a shop that seems to draw your friends in, even if it's for other reasons. But it's taken me too long to get back in here to push this gate project forward. But we're on it now. And the other thing I have to recognize is that I get older, I get a little more hesitant to actually let out the clutch and start committing myself to lengths and cuts and dimensions and the engineered capacity of a system when I didn't hire an engineer. But anyway, we're on it. It's happening, and I'm glad it's happening, and I think I have the design pretty well nailed down. I'm cutting these pieces. This is 3x3 square tube, 3x3 square tube. This one is 1/4 inch wall, this one is 3/16 wall. They're gonna comprise the framework of the outside. I'm cutting it with my portaband. It's not the fastest way. I should cut it with my plasma cutter, but I'm not gonna do that. I need a little bit of forgiveness in this effort that comes with moving a little more slowly. I'd cut it on my bandsaw, but that doesn't cut quite square. It runs off a little bit, and I don't want to start my fit-up challenges 2 steps behind. So we're moving forward carefully. I've been out to the gate. I drew a template. That's that piece of plywood of the actual dimensions compared to what I had on the plan. And with any luck, we'll be able to start welding this stuff together in a day or so. It was several years after I started doing a little fabricating before I figured out that some sections, that is some dimensions of structural steels, come in 20-foot lengths and 24-foot lengths and longer. I mean, if you've got, a big order, you can buy them longer right off the truck. I think you can buy them in 40s, but I'm not sure of that. So anyway, I've had to buy 24-foot pieces on these two because I've got a 15.5-foot run on the bottom and a 5.5-foot run coming up the ends, and I just couldn't squeeze that out of a 20-foot stick. So here we are. I'm gonna have, 2.5 feet? Yeah, 2 feet, 11 inches to add to the boneyard, and who knows, I'll probably use that stuff sooner or later. Now once again, I don't recommend this, but it's what I've got, it's what I feel like doing, and I think it might save me a little time when it comes to welding these up.
The marks that I'm putting on these pieces of tubing right now are critically important. The locations of the interior 2x2 steel tubing pickets are laid out to leave exactly 20 inches of opening in each of the 8 spaces. You will see in a future video why a miss right here will be trouble later on.
Well, I am nowhere near as qualified with the plasma cutter as I am with the skill saw. But I can tell that, 5 or 10 years of doing this, I probably would be. Part of the confusion for me is the consumables and when they're dirty and when they're clean, and anyhow, it doesn't matter. I've blundered along and I've had to shorten this whole thing 1/4 inch because of a miscut that I made right here. But I can afford to shorten that 1/4 inch, and I'm gonna go ahead and make this cut right here, drop that off, grind all this up. A flap disc can make a welder out of even somebody like me. This is how this end turned out. We'll make this last cut, shine it up a little bit, and call her a day.
There are several ways that these corners could be joined, but I'm using what I think you could call a coped corner because it's stronger, I think, and better looking, I'm quite sure.
When a plasma cutter works, it really works great. Well, it's been a while since I got back to the gate, but it's time to do it. I've been stewing on, and I think I have solved the dilemma of how to attach and enclose and make this magnetic latch work, how much space I need for these hinges. And I better have it figured out, because once this stuff's welded together, there's just no changing it. Or at least, I wouldn't want to have to change it. The idea is that this is an electromagnet. This is the piece that will stick to that magnet, and it has 1,200 pounds of direct resistance to pulling off. This is the backing plate that the factory made to attach this with just a little bit of a pivot so it can true itself up with whatever plane this actually exists in. All of this has to be attached to the gate. This represents the style on the latch style on the gate. This represents the post on the latch side. And these are the hinges that are going to attach to the post on the hinge side of the gate. Here we go. Well, I've just about made the classic carpenter's mistake of making things too tight. This enclosure has got to receive this magnet. Man, everything is like a net tight fit, which will just never work. So I've got to move this up a little bit, and my fit up on my weld is not going to be as good as I had hoped. But I got a MIG gun, and a MIG gun will put in all the material you need. So I'm going to nudge this up, pull this end up, and make sure that when it comes time to put this magnet into this little box, it's going to fit. Transfer punches. The idea is you can run one of these through an ordinary fractional drill opening, and they have the center punch machined into the very center of that opening. So I'm going to transfer the center of these attachment bolt holes down into that plate, drill it, tap it, thread that thing on, and figure out how to weld in the permanent attachment. So I'm trying to rig up an interior brace to attach the back that the magnet screws to there, and then the magnet screws through the edge into the side of the housing itself right there. I'm trying not to put myself in a position where the person who works on this cusses the engineer who built it and swears that an engineer should have to spend 5 years in the field before he actually sits down at a design table in the automotive industry. But I tell you what, it's not always intuitive to be able to make the machine do the work it needs to do and still provide access for maintenance. I'm going to know more about this time tomorrow about whether or not I got this right. Okay, I'm just about ready to weld this thing off. Drill a couple more holes for electrical conduit penetration. Tie her all together. But this backing plate is where it ought to be to receive the screws to hold the magnet. It's all shielded. This is the sleeve to receive the bolt for a lock in case the power goes out. I think we're getting closer. Okay, I'm going to bet on this. I've got to drill the plate that goes on here so I have access with conduit and a bolt and various things, but I need paint in there. I don't want that just rusting. So I'm going to do something that I've done a few times with good results, as far as I know it's good results, and I'm counting on you painters to straighten me out. But I'm going to preheat this to maybe 150 or 200 degrees and then spray it with cold Rust-Oleum primer. It dries in a hurry, and then I can go ahead and weld the top on, and at least I made a sincere effort. Well, that's plenty hot. This paint is old. The nozzle's kind of clogged. What we're doing here is, I think, better than nothing, but not much. I'm sure this has been hard to follow. It has been for me too, but here's what we've got. Here's this canister. It's going to bolt, this side is going to bolt to the post. This electromagnet can be taken out by taking that Allen screw out and these two out. Those two thread into this backing plate. This one threads into what is actually the front of the canister. This is the tube for putting the auxiliary mechanical latch in place if the power fails or I don't get hooked. This is going to weld on about like this. 2 hands, he says. So I can access this Allen screw. Electricity will go right through there. These are probably a mistake. I put those in so I can put a tack weld into the edge of that backing plate. Weld the perimeter. The inside is sort of painted. And then it'll simply be to attach some ears for bolting to the post. I'm not going to weld it to the post, but that'll be a project for probably a month from now. I got a lot of work to do on the gate once I get this little puzzle solved. Okay, I'm going to take this thing out so I can just weld and not worry about spatter. Let's see if it comes apart.
Now, if you're just itching to learn to weld and fabricate and make things out of steel, this video might look, intriguing and maybe intimidating because of the tooling and everything, but that's okay. Because for the professional fabricators who are still watching this, I'm sure that watching an old carpenter do his fabricator impersonation is pretty much pure comedy. And by the way, if you are a fabricator and you're seeing the things that could be done differently or better, please chime in the comments, because there's a lot to learn in the comments to these videos. But the truth of all this is that everybody is good at something and nobody is good at everything. And if you want to be good at something someday, the only way to do that is to just start in right now. Just start doing it. And before long, in fact, before you know it, you're going to be pretty darn good at it. Thank you for watching Essential Craftsman, and keep up the good work.